Okay, so with no questions to start off with then, I am going to start with the new lesson. I'm going to share my screen. Okay, you should see my screen now. We'll zip ahead to the beginning of the lesson. So here are the 4 main objectives for today. Greetings, Dan Thompson. Good to have you. So here are the 4 objectives for today's lesson. Everything is basically a relation, but only special ones are functions. We're going to need to tell when is it special in a function and when isn't it. Secondly, this is a big one, using function notation and being able to evaluate. Welcome. Let's see. I'm trying to remember now. This is you always appear as Siloban.
No, Siobhan. It's a ghost name. It's Caitlin, Professor.
Welcome, Ghost. Anyway, good to see you. I got no questions, and it got past 10 o'clock, so I'm starting the new lesson. We can go back later and ask questions if you want.
Not a problem. I didn't have too much problem with the homework. Thank you.
Okay. Third objective, find the domains of the functions. And fourth, use functions to model, of course, and do any kind of problem solving. The 2 main guys responsible for this I just thought I'd show you. I always like to keep a little bit of a touch with history. I just want to make a comment about the guy on the left. The guy on the left is Leibniz, and he's one of the 2 co-discoverers of calculus. The other one is a German the other one is very famous, Sir Isaac Newton. But anyway, these 2 guys, Leibniz and Handmann, really got the function concept going. Without the function concept, it's really tough to think of calculus properly. So this is kind of big stuff. And then we should give a nod also to Leonhard Euler, first one to really use function notation. F of x, the f of x thing, which I know maybe sometimes students are bothered by that notation, but again, you'll see hopefully today it's quite important. Okay, so I use these slides from the publisher to hit some of the main points today. So notice I edited this slide a little bit. So our relation is, as they say, a rule of correspondence that relates 2 sets. And I notice I put in the word any. Welcome, Ashley and Jordan. Glad to have you.
Thank you.
Without questions, I dove in right away. We're going into the new lesson. If you want, later we can go back and hit questions. So a relation is any connection between 2 sets. And the emphasis on the word any, that's why I underlined it. So in other words, nothing special here. Anything is a relation. What's special is those relations that are also functions. So that's where we're headed. Yeah, and the relationship comes out in ordered pairs. So the relationship between R and I in this formula right here. I equals 500R, interest formula. Or, yeah, and more typically we will refer to the relationship of X to Y, good old ordered pairs. So ordered pairs of without any pattern at all is a relation. Okay. Now we're going to get to the special, the function. A function is a special kind of relation. Welcome, Justin. Good to have you here. A function is special in that, how does it say it here? Assigns to each element exactly one element in the set B. So you can't, it can't be, I'm trying to think of the right word. What do you call that when you can't make up your mind? You're flip-flopping from one thing to the other. You know.
Indecisive?
What's that?
Indecisive?
Yeah, that's good. I was trying to think, what do you call it when somebody has, you know, like a split personality? Anyway, the idea that if I gave you a point, you could say, well, I don't know. I think the answer today is 10. Oh, I don't know. Tomorrow maybe it'll be 15. You know, that would be a relation. Anything goes. But with a function, like for example, when we go to the store, if we buy a gallon of milk, there is only one price that we can charge that day. They can't charge me one thing and then Caitlin another thing. There. So anyway, functions, we're very used to them. This little picture on the bottom, you start with the domain is like your x values, and for each value of x, notice the blue lines go over, there is only one answer, B. You know, so like for each x, there is only one y. The x's are called domain, and the answers, the y's, are called range. You know, we've played around a little bit with domain earlier this year, so that's not totally new. Yeah, here's the book's way. Instead of using circles, they use rectangles. But notice each x only goes to one particular y. It can't like go to a bunch. Each one goes to one place. That's what a function does. So here's a little quiz with the answers showing, okay? So here's a set of ordered pairs. Is that a function or is it just a relation? Notice it says it's a function, and the reason, does any x value go to more than one answer? No, we don't even have a repeat of any x values, do we? We've got -2 goes to 3, 0, 2, 4. We never have a repeat. As opposed to, look at the one down below. Why is this one not a function? Can somebody answer that? Why is that bottom one not a function?
Because the x repeats. You have multiple -1s.
Yeah, and you got to add one more thing. It's got a repeat, and you notice that the repeats go to different places. So the first -1, the answer is 1. But the second -1, it's a different answer. It goes to -1. That's what you can't have in a function.
Okay.
Boy, that word I was looking for almost popped into my head. Yeah, it'll still come. Okay. So we usually use for functions f, I guess yf, because that's the first letter of function. But when we need a second one, we'll take the letter after it. So you'll frequently see f, g. But functions, they could be named anyway. Here's that Leibniz notation, f of x. F of x notation has a great advantage. If, for example, next to my arrow there, let's say that's our function. Take whatever I give you, double it, and add 1. Okay, now what happens when I apply that to a 2? Take 2, double it, 4, and add 1. The result is 5. Okay, so f of 2 is 5. Or maybe your teacher in high school said f at 2. Did any of you have teachers that did that? Or did any of your teachers say f at 2? So in other words, just about all of you, your teacher used to say f of 2. Or you don't remember. Well, anyway, they're both proper. Okay, how about when you plug in a 0? Well, double a 0 and you get 0, add 1, 1. How about when you plug in an A? Double the A and add 1. How about when you plug in a box? Double the box, 2 box plus 1. Now how about if you plug in a pickle? Double the pickle and add 1. Now I'm being a little ridiculous, but I'm trying to show you that you literally take whatever is given and you substitute it in place of the x and just carry out the operation. Okay. Next slide. Yeah, here's an example. If we were given this function right here, f of x equals x squared minus 3x minus 1, then what's f of negative 2? And you can see they went ahead and substituted it in. They did the arithmetic. And the answer is 9. So we say f of negative 2 is 9. What I love about that notation is that's just like an ordered pair. Negative 2, comma, 9. So that's the advantage of function notation, is it relates to an ordered pair real well. And we are all very familiar with ordered pairs. If I didn't say it already, Sam, welcome. Good to see you here.
Good morning, Professor.
Yeah, good morning. How's it going?
Not too bad.
Well, good. I started right on time, and I think only Brandon was here at the time. We didn't, at the moment, have any questions, so I dove right into the lesson. If later, what I'll do is when we get toward the end, I'll see if anyone wants to go back and ask some questions about the previous assignment. So anyway, continuing here with these slides. Yeah, now take a look at this. You notice over here, I'm going to change colors here. You see, this time we've got a function, and this time we're trying to find something not quite as simple as f of 2 or f of 3. It's actually an algebra expression, f of x plus 2. So what do? The same thing. Substitute. Wherever there's an x, you are now going to put an x plus 2. Then go ahead and carry out the algebra. And now it gets a little bit messier. You've got to, do some of your basic algebra. So here, f of x plus 2 turns out to be 4 minus x squared. I'll just pause here. Does anybody have anything you want to ask about? I'm hoping this looks pretty familiar. Okay, I'm going to move on then. So remember we've talked about this word before? Earlier this year, remember we talked about domain? And when you wanted to find the domain of a function, do you remember what we were basically doing is trying to figure out all the numbers x can be? Or another way to put it, are there any numbers x can't be? So if you look at this particular function right here, f of x equals 3x plus 5, is there any number you can't plug in for x? I mean, even like, could you plug in the square root of 2? Or 1/9? Yeah, it doesn't matter. You could, no matter what it is, you can multiply by something and then add, right? So this one, the domain is simple. It's all, there's no restriction here. Um, here's where you can get into a little bit of trouble, right? You know that using the real numbers, you can't take the square root of just anything, can you? We know that square roots of negatives give us these imaginaries. Well, nothing wrong with those, but over the reals, you can't do that. So what won't work for x here? Anything that would make that thing under the root negative, right? So, for example, x equals 0 would create a problem, because then you'd have the square root of negative 3. So what's going to work and what's not going to work? Well, let's find out. Let's take that thing underneath the root and let's find out when it's 0 or above. And you can see, oh, any number 3 or above is going to make that come out legal. And remember, you can write that this way, or in interval notation, couldn't you write that like this? So one of the things you'll have to be able to do is determine a domain. So you're looking for, well, what can't x be? And then that leads you to, what can it be? So, I don't know, this is just some more practice on function notation. Here you have the function f of x equals 3x minus 3. What's f of negative 3? So you just plug in negative 3 for x. 3 times negative 3 is negative 9. Negative 9 minus 3 is negative 12. What's f of x plus 1? Plug in x plus 1 where there was an x. Okay, we can simplify it a little bit, but the answer comes out to 3x. That's as good as we can do, right? So what is f of x plus 1? It is 3x. So, I mean, that literally represents this ordered pair. When you plug in an x plus 1, out comes a 3x. What's f of triangle? Plug it in for x, 3 times triangle minus 3. What's the ordered pair? You plug in a triangle, what comes out? 3 triangle minus 3. Okay. Now, you're going to start seeing a lot of this guy. This is what is called a difference quotient. Let's see. I kind of threw that in the middle of nowhere, so hang on. I'll cover that in the next slide. All right, sorry about that. That really shouldn't have been in there. The slide right after this one, we'll talk about that. How about, what's the domain of this one? Is there anything that would cause the denominator to be illegal? Well, you know the only thing you can't divide by is 0, right? So is there anything that would cause this denominator here to be 0? Well, let's find out. Take the denominator and set it equal to 0. Oh yeah, there's two things that would make that come out to 0. 1 and negative 1. So what's the domain? Everything else. So this is, maybe you might think of this as a cop-out, but what does that domain actually say? It says, well, everything except 1 and negative 1. That's what that means. All x such that x is not equal to 1 or negative 1. Why do we say it that way? Can you imagine having to list all the correct answers? Well, you'd never be done, right? There's an infinite number of things that can be put in for x here. So, I mean, it's stupid to start listing them. So what do? You just list the ones that can't be. Okay. Now we're going to get to that difference quotient guy. Okay? So, I don't know, if you got some note paper, the first thing, I think I would just write this down, okay? Write down the term difference quotient and then also write down this expression. And then I'm going to show you where I got that from. I'm a little concerned that we only have 7 people here in class. Okay, did you guys all get that down? Now, let me show you where that comes from. So let me get rid of this cover here. Okay, so what I did is I just made a first quadrant sketch here, and I picked 2 generic points. This one over here. Now, in terms of functions, the x-coordinate of this point is x, and the y-coordinate, we're going to start using this in place of y a lot, is f of x. Okay, and then for the second point, I just moved over h, and this point up here is what? Well, the x-coordinate is x plus h, and then the y-coordinate is whatever f of x plus h is. So here's my 2 generic, these are the 2 points that I want to focus on. Okay. What's the slope of this curve, right? This graph? Well, wouldn't it just be y2 minus y1 over x2 minus x1? Well, what's y2? F of x plus h. See it up here? F of x plus h minus y1 f of x over, and now x2 minus x1. What's x plus h minus x? Isn't it h? X plus h subtract x would just put you back at h. So all this is a slope formula. Do you see that? All that is y2 minus y1 over x2 minus x1. Slope. Okay, now I'm spending some time on this because now what we're doing is we're starting to touch calculus. Okay, well, not quite, but we're getting ready. Slope is very important in calculus. And so I wanted to nail down that this is just a generic slope formula. It's written a little differently. Instead of y2 minus y1 over x2 minus x1, it's the same thing, only using this function notation. Okay, we're going to be seeing a lot of this. And I should really even put a rectangle around that because that's hugely important. Okay? That is something you're going to want to become really familiar with. All right, let's see. I think I'll even highlight that a little bit. Let's make it, well, didn't quite want to do that. Yeah, I goofed that up. Anyway, you get the idea. That's important. Okay. Next. So, here's a function. F of x squared plus 3x plus 7. Not a very complicated one. Do you recognize this over here on the right? That's that difference quotient I just showed you on the last slide. So this is going to be really big. You're going to want to take a function, and from the function, whoa, from the function, find its difference quotient. Okay, well, I know what f of x is. That's right here, x squared plus 3x plus 7. But what's f of x plus h? How do you find f of x plus h? Oh, you plug in x plus h wherever there's an x. Do you see how I did that? X squared now becomes x plus h squared. Plus 3x now becomes 3 times. I just replaced x with x plus h. I cranked it out, and here's what it came out to. Okay, so now I know what f of x plus h is, and what do I have to do to find a difference quotient up here in the top right corner? I need to subtract the original function from f of x plus h. Do you see how I did that right here? There's the f of x plus h on the top, and then on the bottom, there's the function. Do you see why did I spread it out like that? Can anybody tell me? The original function, x squared plus 3x plus 7. Why did I spread it out?
It's easier to track, so you see what you're doing.
Okay. Do you see how I lined up the like terms?
Mm-hmm.
X squared, 3x, 3x. So I just lined it up. So, okay. And by the way, this is really subtraction of the whole quantity. I'm just saying subtract that whole thing. So that's going to be, so x squared minus x squared, gone. 2xh minus nothing is 2xh. H squared minus nothing, h squared. 3x minus 3x, gone. 3h, still there. 7 minus 7, gone. So do you see where I came up with this part as the answer to that subtraction? So then why did I divide by h? Because if you look up the difference quotient, don't you always have to divide the difference quotient by h? Okay. Well, look at h is, if you look at the numerator, you can factor in h out, factoring, and then the h's cancel. And there she is. What is the difference quotient for this particular function? 2x plus h plus 3. I know. What's h? Well, remember, here, let me just go back. What was h? H is just whatever distance I move to the right to put that second point in there. And you'll see later we're going to shrink h down so it gets incredibly tiny. But for right now, it's okay to just have an h in here. So here's our first difference quotient. Given a function, find f of x plus h minus f of x divided by h. The big step, really the one that requires the most work, is finding f of x plus h. Substitute x plus h in, crank it out, then easy, subtract the original function and then divide it by h. Simplify. That's called a difference quotient. Probably the most important thing from this lesson. I see, as I'm looking ahead at the assignment, I don't know if you have your books handy, but these important, what I'm calling really important, start at number 77. That section, you see that? It says find the difference quotient and simplify your answer. Well, we just did a problem almost just like 77. Okay? We're going to do some more. So now I want to show you one that's a little bit more of a challenge. Okay? In fact, this one is what? Kind of like number 81 in the book, where you start off with an algebraic fraction. Okay? So here's a fractional function, and we are again to find the difference quotient. So what does that mean? I got to find f of x plus h. So I got to take this expression, and every place there was an x, I have to replace it, but with an x plus h. So do you see how I did that from here to here? You see how I just took every x and replaced it with x plus h? And then over here, well, I had to square x plus h. Do you remember how to do that, guys? It's not just x squared plus h squared, right? You get the middle term, the 2xh. And then here I just multiplied by 2. Yeah, I'm off the screen a little bit there. Well, yeah, the plus 1, I ran out of space, so I put it on the bottom there. See that? Okay. Now that I know what f of x plus h is, I have to subtract the original function from that. Well, here's the original function. See it up there on top? And then I have to take all of that and divide by h. Now, this is still a mess, and I'm not going to go ahead and do it right now. But I just want you to see the mechanics. So here, a difference quotient. Wow, this would take us a while to finish this up. I mean, it's algebra we've learned how to do, but look at to get a common denominator here, kind of ugly. Okay, let's go on to a more typical problem here. Yeah, maybe this is a little bit easier. 1 over t minus 2. So again, we have a fraction. Find the difference quotient. So don't let the t, that's just the same as an x. So here's what we want to find. F of t plus h minus f of t all over h. First step, find f of t plus h. So wherever there's a t, plug in a t plus h. Well, that was easy. Okay, now take that, f of t plus h, and subtract the original function. Divide all of that by h. Okay, now I got to get this top together, so I need a common denominator. So now we'll do the common denominator thing. You can tell that the common denominator is what? T plus h minus 2 times t minus 2. This one over here is missing the t minus 2. So I multiplied top and bottom by that. This one over here is missing the t plus h minus 2. So I multiplied top and bottom by that. I'm going to just resize a little bit so you can see the bottom there a little bit better. Okay, so after you multiply that out, you get this. The numerator simplifies down to negative h. Now, how do you take one fraction and divide by another one? By the way, this h could be thought of as h over 1 down here. Don't you in multiply? So this fraction gets flipped upside down. And do you see then where I got this extra h down here? So when you take this thing up on top and multiply it by 1 over h, that's where this h comes from right here. And then, beautiful thing happens. You can cancel the h's. Don't forget about the negative on top, though. So finally, here it is. Here's your difference quotient. Now, I know it's a little overwhelming. Fractions are a little bit harder to do. Let's see if I have an easier one to look at. Was anybody still writing this down? I guess you can look at the video too, but okay, let's go on to this one. Okay, again, this is a lot like number 77 in the book. It's just a straight polynomial function. Okay, what's the difference quotient? First, I got to find f of x plus h. This takes a little bit of work. Everywhere there's an x, I have to substitute in an x plus h. Of course, there's 3 of those. So everywhere there's an x, do you see how I replaced it with an x plus h? And then look at this ugly thing. You got to take x plus h and cube it. That means you got to take x plus h times x plus h, work it all out, and then take the answer times x plus h again. Yeah, well, don't do that right now, but when you put all of that in there and hash this whole thing out, this line is what results. Okay, then subtract the original function from it. Again, you see how I lined up the terms? So that would be a little bit easier to subtract. Goodbye 2x cubes, goodbye 2x squareds, goodbye negative 6x's. And this is what's left. And then the last step is divide by h. Like, by the way, you're going to get used to this. H factors out of the top. And then, voila, you can cancel and you wind up, you won't have a denominator. So here, this thing in parentheses here is your difference quotient. Have any of you done this before? Difference quotients? No? I'm getting one no. I don't know about the others. No? Okay. The good news is this is pure algebra. There's nothing exotic here. It's just doing stuff you already know how to do. So the bad news is frequently takes a while to do, as you can see on this particular page. Okay, let's take a look at a nice easy one. All right, maybe I shouldn't have given you all those tough ones first. Here's a nice easy one. Let's just take a simple function like 2x minus 1. Find the difference quotient. So first thing you got to do is find f of x plus h. So take x, replace it with x plus h. Well, that wasn't very hard, right? Okay, now take f of x plus h, subtract the original function, 2x minus 1. Well, look at the 2x's go away, and the minus 1's go away, and all you wind up with is a 2h on top. And an h on the bottom, and the h's cancel. Now that one you ought to like. There's the answer to the difference quotient. So they don't all have to look so as messy as the previous two that I showed you. So once again, I keep going back to this, right? I keep going back to this thing up on the top here. You've got to learn. You gotta and all that is a slope. So what you're really doing is a big old slope. Okay, and just returning, this is the one we just worked on. Is there anything on this slide that you don't get or puzzles you? I know you're new to this, so you're probably spinning a little bit yet, but I mean this is fairly straightforward, isn't it? I think so. Okay. Now, let me just show you what happens when you do it with a square root. It gets a little messy again. So this time, you can see here's our original function. Square root x minus 3. Okay? So when you want to find, and by the way, do you see why this is here? Why is that comma x is greater than or equal to 3 there? Well, what would happen if x wasn't greater than or equal to 3?
Negative.
Yeah, we'd have an illegal square root, okay? So all that is, this is the domain. It's just saying, yeah, well, you can't do this unless x is 3 or bigger. Okay. So what's the first thing in a difference quotient? You have to find f of x plus h. So here we go. Wherever there's an x, plug in an x plus h. Well, that was easy. Now take f of x plus h, subtract the original function, and divide by h. Okay. Man, how am I going to get rid of the h on this one? Well, you remember good old conjugates? Notice I multiplied top and bottom of this fraction by the conjugate of the top. See that? The same thing, only this becomes a plus. Okay. So, all right. So I have good news. What happens when you multiply conjugates? I'm going to wait for somebody to answer that. What happens when you multiply something by its conjugate?
Things cancel out.
Okay. That something cancels out. You get the difference of two squares, right?
Mm-hmm.
So in other words, it's this guy squared. Well, that's just that guy without the root. Right there. Same guy without the root. Minus the other guy without the root. Oh, that's cool. Goodbye roots on the top. The bad news is you now have junk on the bottom. You see how the roots wind up on the bottom? But that's okay. Because you notice, by the way, if you simplify the top, x minus x, goodbye x, negative 3 minus a negative 3, goodbye negative 3. All that's left on top is an h. And look at the h's cancel. And there it is. There is your difference quotient. By the way, you know you're done with the difference quotient when you can get rid of that h. When you've done that, well, you can't get rid of all the h's, but you get rid of, you're going to see a cancellation. Notice there's still an h in here, but yeah. Okay. Yeah. Maybe I have difference quotiented you to death by now. Actually, we need to do more, but I'm going to let you guys work on some of those. Okay, let's look at a couple problems from the assignment. So if your book is handy, open it up to page 196. Here's number 24. It says evaluate the function at each. All right, so if you look at 24, the function is what? 7 minus 3y. And then they want to know what's g of 0. So what, here, let me just write that function down. So, what's g of 0? Well, plug in a 0 wherever you see a y. Okay, 7 minus 3 times 0. What's 3 times 0? 0. What's 7 minus 0? 7. Pretty easy, right? So if you plug in a 0 in place of your variable here, you're going to get a result of 7. What happens when you plug in 7/3? What's 7/3 times 3? 7, right? And what's 7 minus 7? 0. Okay, and now, I mean, those are pretty simple. That's just arithmetic. But what about this one? What's g of s plus 2? Well, this time you have to plug in an s plus 2 where the y was. Okay, so I did that. You multiply this out and you get negative 3s minus 6. Well, I can't do anything with the s because I don't have any other like terms, but I can do 7 minus 6, which of course is 1. So this would be it. And I can't do any better because I don't know any more about s. So how do you find functional values? You just substitute. Substitute for the variable, crank, and just do the arithmetic, or in this case, a little bit of algebra simplification. On to another one. This is not a specific problem, but there are problems like it. Same part. If this is the function, 3x squared minus 6x plus 9, can you find f of negative 1? Sure, you just take negative 1 and plug it in for x. Negative, and then you could just crank it out, do the arithmetic, right? Could you find f of x minus 4? Sure. Wherever there's an x, plug in an x minus 4. Work it out, combine, and in this case, that would be where you'd end up. So finding functional values is just substitute and simplify. There's not much there. Pretty simple. Okay, let's just take a look at number 81. So now we're into the difference quotient part again. So this is on the bottom of page 97, number 81. You see down there that the function g of x is equal to 1 over x squared. And you are supposed to find, you see what they put there, g of x, I just copied it, g of x minus g of 3 over x minus 3. You don't have to worry about this, they just told you this because that would create division by 0. That just, so the problem is still legal. Okay, so what do? First you got to find g of x plus h. I'm sorry, you just got to do this. What's g of x? 1 over x squared. What's g of 3? 1 over 9. All over x minus 3. Okay, notice I need a common denominator to bring the top together. Top and bottom of first fraction by 9. Top and bottom of second fraction by x squared. Bring it together. Looks like this. Now, think of this over 1 down here. Invert and multiply. And just simplify. So that's really substitution 2. Let's look at one more, number 82. Again, bottom of page 197. Okay, so this time the function is 1 over t minus 2. You are supposed to find f of t minus f of 1 over t minus 1. So f of t, just copy what's right here, 1 over t minus 2, which I copied right there, minus, I changed that, you'll see why, that was minus, right? F of 1. What's f of 1? Well, what happens when you plug in 1 here? You get 1 minus 2, negative 1. What's 1 over negative 1? Negative 1. So this really is minus a negative 1. Well, what happens when you subtract a negative? It becomes a positive. That's why I changed those to plus signs. Okay, I went ahead and got a common denominator by multiplying top and bottom of the second fraction by t minus 2. Now I could combine it, invert and multiply. I'm not sure why I have the comma 1 there. Let me think that through. Oh, I'm saying, I get it now. This is your answer. What this is saying is t can't be 2 or 1. Do you see why? Well, if it was 2, this is garbage, right? And if it was 1, then wouldn't this thing up here have been garbage? You can't have any fractions with 0 on the bottom. So this is just this is simply saying, hey, I know t can't be 2 or 1 because this whole operation would be illegal then. But really, here's your solution. 1 over t minus 2. Okay, let's pause for, let's take some questions. Let's start with questions on the new stuff, the stuff I talked to you about today. Sorry, I kind of dumped on you, gave you a lot, but this lesson, I guess this lesson's more loaded than I thought. You want to go back? Yes, go ahead.
I'm sorry. I was hoping to go to chapel today. May I be excused and just watch the rest of the video later?
Well, certainly. Sorry, I guess we have, what, 8 minutes? Yep. Go ahead.
Thank you. I appreciate it.
Good girl. You can give me a report on chapel. No, I'm just enjoy it. Thank you.
Thank you.
So the rest of you, anybody want to go back to any slides, ask any questions about the new stuff, first of all? I know it's maybe a little overwhelming, so we'll have to get, and don't forget there is another video up too. So keep that in mind. There's already a video for 2.2. Now we'll have kind of a second one here. Did anybody have any questions on the old stuff? On the assignment that was due for today, 2.1? Okay, here's the new assignment. It's the old multiples of 4 thing, 1, 5, 9. And this time you end at 107. So I'm going a little farther this time than we normally do. This is stuff you just got to get in there and do and practice. So it's about 100. It's about what, 20, 25 problems approximately. Any questions? Sorry, it was kind of fast and furious. Thank you for being here. I'll see you tomorrow.
Professor?
Yes.
So, for Friday's homework, should I just do what's posted online?
Because you're not going to be there Friday?
Yeah.
Yes.
Okay. Thank you.
Thanks for asking, Justin.
Have a good day, Professor.
Thank you also.
Thank you.
Thanks, Ashley. Bye.
Bye.